Okay, I hope I'm audible to all students who are attending this practice lecture for mathematical methods for economics course. In this particular practice lecture, we are going to solve a couple of problems based on our module functions in several variables. So I can write the heading as practice problems based on functions in several variables. So we are going to solve a couple of numerical problems based on the concepts we have covered in our lectures on functions in several variables. Okay, so one of the major concepts we have covered is partial derivatives. So in this particular lecture, let's solve a couple of problems based on finding partial derivatives. So let's look at question number 1 for practice. Find del z by del x and del z by del y for each of the following functions. Find del z by del x and del z by del y for each of the following functions. So we are given the first function, z is equal to 3x cubed plus 5x square y plus xy squared plus 2y cubed. Okay, so let's quickly find del z by del x. Remember, when we are differentiating partially with respect to x, we treat y variable as a constant. So when you partially differentiate this with respect to x, you get 3 times 3x squared plus 5y is a constant. The derivative of x squared is 2x plus y squared is a constant. The derivative of x with respect to itself is 1 plus 2y cube is a complete constant. Its derivative is 0. So I can write that del z by del x comes out as 9x squared plus 10xy plus y squared. Okay, let's look at the second part. We are given z is equal to x plus x e to the power y plus y e to the power x. Okay, so let's quickly solve for this particular part. For the first part, let's also quickly find del z by del y first, because the question asks us to find both del z by del x and del z by del y. So for the first part, if I partially differentiate this function with respect to y, I treat x as a constant. So the derivative of 3x cubed is 0. The derivative of 5x square y, 5x square is a constant. The derivative of y with respect to itself is 1. Then x here is a constant. The derivative of y square with respect to itself is 2y plus the derivative of 2y cubed with respect to y is 2 times 3y square. So I can write, let me erase this part off and let me write the complete answer for del z by del y. So del z by del y is 5x square plus 2xy plus 6y square. This is the complete answer for part 1. I have found out del z by del x and I have found out del z by del. Let's look at the second part. We are given that z is equal to x plus x e to the power y plus y e to the power x. Let's first find del z by del x. To find del z by del x, I partially differentiate the z function with respect to x, treating y as a constant. The derivative of x with respect to itself is 1. E to the power y is a constant. The derivative of x with respect to itself is 1. Again, y is a constant. The derivative of e to the power x is e to the power x. So I get 1 plus e to the power y plus y e to the power x. This is del z by del x. And if I find out del z by del y, to find out del z by del y, treat x as a constant. The derivative of x is 0 plus x is again a constant. The derivative of e to the power y with respect to y is e to the power y plus e to the power x is a constant. The derivative of y with respect to itself is 1. So our answer for del z by del y is x e to the power y plus e to the power x. Okay, so hoping students have understood the complete solutions to parts 1 and 2. Moving forward, let me erase This whole part off, and let's look at question 1 only, part 3. So we are given that z is equal to log x plus 5 to the power alpha, y plus 2 to the power beta. Let's quickly solve this. First, let's find out del z by del x. Before that, let me first of all write this using properties of log. So consider, let me simplify this expression first by using properties of log. So consider z is equal to log of x plus 5 to the power alpha, y plus 2 to the power beta, which I can write as log of x plus 5 to the power alpha plus log of y plus 2 to the power beta. And this I can further write as alpha times log of x plus 5 plus beta times log of y plus 2. This is my expression for z. I've used properties of logs, which students should know after attending my theoretical lectures on exponential and logarithmic functions. So once I've got this final expression, I'm now going to partially differentiate this with respect to x and y. So therefore, del z by del x is going to be, if I partially differentiate this with respect to x, I treat y as a constant. So alpha times log of x plus 5 derivative is 1 over x plus 5. And x plus 5 derivative with respect to x is 1. Plus beta log y plus 2. Now log y plus 2 is a constant. Beta is also a constant. Derivative of two constants is 0. This whole term is a constant by this. Because when you are partially differentiating with respect to x, remember you treat y as a constant. So log of y plus 2 is a constant, beta is a constant, their derivative is 0. So my answer is alpha over x plus 5. That's del z by del x. If we find out del z by del y, we partially differentiate the z function with respect to y, treating x as a constant. So alpha log x plus 5 is a constant, complete constant when I'm partially differentiating with respect to y. So its derivative is 0 plus beta times log y plus 2 derivative is 1 over y plus 2 times y plus 2 derivative with respect to y is just 1. So my answer is beta over y plus 2. That's del z by del y. Okay, let's look at part 4. So if I erase all this off, question 1, part 4 is as follows. We are given that z is equal to ax to the power 5 y square. So again, if I find out del z by del x, it means I'm partially differentiating with respect to x, treating y as a constant. So ay square is a constant. The derivative of x to the power 5 is 5x4. So my answer is 5 a x to the power 4 y square. And when I partially differentiate z with respect to y, I treat x as a constant. So it's ax5, the derivative of y square is 2y. So my answer is 2a x to the power 5y. This is del z by del y. Okay, so let's look at part 5 now. So part 5 is as follows. Z is equal to e to the power x square minus y square. So let's work out the solution for this. Let's find out del z by del x. Now we have to use chain rule here. We have to be very careful. Okay. Remember e to the power anything. First of all, the derivative is e to the power x. The derivative of e to the power x square minus y square is e to the power x square minus y square times. Internally, the derivative of x square minus y square is what? When I'm partially differentiating with respect to x, the derivative of x square is 2x minus y square is a constant because you are partially differentiating with respect to x. The derivative of y square is 0. So my answer is 2x e to the power x square minus y. That's del z by del x. If I work out del z by del y, again, the derivative of e to the power x square minus y square is e to the power x square minus y square times. If I internally differentiate x square minus y square with respect to y, I treat x as a constant. The derivative of x square is 0 minus the derivative of y square is 2y with respect to y. So I get e to the power x square minus y square times minus 2y which comes out as minus 2y e to the power x square minus y square. So I hope students have understood this. Let's look at the next set of parts. So part 6. We are given that z is equal to x square e to the power y. Okay, so this is very easy. Del z by del x will be, when I'm differentiating with respect to x, e to the power y in this case is a constant term. So the derivative of x square is 2x. My answer is 2x e to the power y. And if I find out del z by del y, okay, I treat x as a constant. So x square is a constant in this case. The derivative of e to the power y is e to the power y only. So my answer is x square e to the power. Let's look at part 7. Okay, so it's as follows. Z is equal to square root of x plus y over x minus y. Okay, so first of all, I can write it like this. Z is equal to x plus y over x minus y whole to the power half. And if I now find out del z by del x, first of all, it's a composite function. So I apply the power rule first. So it's half into the whole function to the power half minus 1 times. Now within the expression x plus y over x minus y, I apply the quotient rule because it's a fraction. To fraction functions, we apply the quotient rule. So it's denominator, which is x minus y, into the derivative of the numerator with respect to x is just 1, minus numerator into the derivative of the denominator with respect to x is again 1 over denominator square. This is the famous quotient rule. So I get del z by del x as half x plus y over x minus y to the power half minus 1, which is minus half, times x minus y minus x minus y over x minus y square. X and minus x cancel out. I get half times x plus y over x minus y to the power minus half times minus y makes it minus 2y over x minus y square. 2 and 2 cancel out here. So I get therefore del z by del x as, I get it as minus y over x minus y square times x plus y over x minus y to the power minus. Okay, this is my answer. Similarly, I can erase the initial part and I can find del z by del y on the top. Erasing this part off. Let's work out del z by del y on the top. So del z by del y will be, again, first I apply the power rule to this. So it's half into x plus y over x minus y to the power half minus 1 times, I apply the quotient rule to x plus y over x minus y. So it's x minus y into the derivative of x plus y with respect to y is 1 minus x plus y into the derivative of x minus y is minus 1 over with respect to y is minus 1 over the denominator square, which is x minus y square. So what do I get? This is half times x plus y over x minus y to the power minus half times x minus y minus, this is plus x minus y. Minus into minus will make it plus here and minus into plus will make it minus here. Or x minus y square. If I work this out, I get, so basically some things get cancelled out. So I get, so I get x here because y is getting cancelled out. So y will also get cancelled out, guys. This is plus. Let me make a small correction, please. This is going to be minus y. This is going to be plus y. Why? Because this minus and this minus will also make it plus. So now minus y plus y get cancelled out. So it's half times x plus y over x minus y to the power minus half X and X make it 2X over X minus Y square. 2 and 2 get cancelled out. So what is my answer? Therefore, del Z by del Y for this question is X over X minus Y square times X plus Y over X minus Y to the power negative. So this is my answer for del Z by del X. And this is my answer for del Z by del Y. So I hope all students have understood this particular question. Okay, let's look at part 8. This was part 7, question 1, part 8. We are given that Z is equal to X square over Y cube. Let's find del Z by del X. How do we do that? We apply the quotient rule. Denominator into the derivative of the numerator is 2x minus numerator into y cube derivative is 0. Because in a differentiating partially with respect to x, you treat y as a constant. Over denominator square, y cube square. So it's going to be 2xy cube over y to the power 6, which is 2x over y cube. And if I find out del z by del y, again I apply the quotient rule. Denominator into the derivative of x square is 0. Minus x square into the derivative of y cube is 3y square over y cube square. So this is going to be minus 3x square y square over y to the power 6. This is minus 3x square over this and this cancel out. Power is 6 minus 2, which is 4. So it's minus 3x square over y to the power. Okay, so again, I hope students have understood this. And now let's look at the next part, question 1, part 9. Z is equal to 2x plus 3y minus 10 over xy. Del Z by del X will be, again I apply the quotient rule. Denominator into the derivative of the numerator with respect to x is 2 minus numerator, which is this whole expression, times the derivative of the denominator with respect to x is y over denominator square. So it's going to be 2xy minus, if I multiply this expression inside, I get 2xy plus 3y square minus 10y or xy square, which I get 2xy minus 2xy minus 3y square plus 10y or xy square. This and this cancel out. My answer is 10y minus 3y square over xy square. This is my del Z by del X. And if I find out del Z by del Y, its denominator into the derivative of the numerator is 2. Let me correct myself, guys. I went wrong here. Denominator is xy. The derivative of the numerator with respect to y is 3 minus the numerator, which is 2x plus 3y minus 10 times the derivative of the denominator with respect to y is x over denominator square. If I open up, this is 3xy minus 2x square plus 3xy minus 10x over xy square. So I get del z by del y as 3xy minus 2x square minus 3xy plus 10x over xy square. So I get 10x minus 2x square over xy square. This is my del z by del y. So I hope all students have understood this. And now a homework problem for all students who are attending this practice lecture. This is something students can solve at home. Find del z by del x and del z by del y for the function z, which is x square plus y square cube. And I'm writing the answers for all students. Del z by del x is going to come out as 6x times x square plus y square square, and del z by del y will come out as 6y times x square plus y square. These are the answers which all students are going to get. So I hope all students have understood and enjoyed this particular practice lecture. I stop in this lecture. In the next lecture, next practice lecture, we continue with more practice problems on partial derivatives. We continue with more practice problems on partial derivatives in the next lecture. So I hope all students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.